video, I'm going to show you how you get this video analysis software. It's called Tracker. Go to Google, search for Tracker Physics, and it will be the first hit. After clicking on it, you'll be shown to this website where you can download the tracker. As well as the trackersample.jar. Download these two files into your computer. For me, I downloaded into my desktop, which you can see as these two files, the tracker and the tracker sample. Right click and extract the folder for the tracker sample, and you will see that all the videos that are shown by Douglas Brown are kept in this folder. Now I'm going to show you how to open the video analysis software called the Tracker. The Tracker opens. You can go to File to open up any previously open project .trk, but for my case, I'm going to show you how you can import a new video. Navigate to the video that you want to analyze. For me, for example, this is the file that I want to analyze. Click Open, and the video will be loaded. Here you can see this is the timeline of which you can use your mouse to scroll. You can click the play button, which will play the video. I'm just going to move it around to locate the position of which the ball is released. Go to Axis and drag the axis over to the position of the ball, which I want to tell the tracker analysis tool that this is the position of the coordinate system. I will then select the tape tool to tell the software where is 1 meter. So because this video has been properly filmed, so you can see that I will now change the length to 1.000 meters with an angle of negative 90 degrees. With these two, I'm going to lock the tape as well so that it doesn't interfere with the rest of my analysis. I'm going to choose to create a new track. Click on this button, select a point mass. You could try the other examples. Let's say the mass is called mass A. I'm going to select until a time frame where I'm comfortable for this to be trimmed and analyzed. So I'm going to click on this button called the clip setting. So to select the start frame, you can see on the bottom left is stated as 10th frame. I'm going to leave the end frame the same. You can change the other variables. I'm just going to click OK. And now you can see that the computer software is able to. Tracker 3.1 now comes with an auto tracking function. Select auto track and just follow the instruction. In step 1, I will select the feature which I want to auto track in part 1. I'll click next and it will prompt me to go to target, and I'll click next, and this is the accepted score. Just leave it as default and press start. So you can see that it tracks automatically until it cannot determine the next position, which for this case I'm just going to try to navigate to the correct position and accept. After accepting, I'm going to drag to find the new position again. There could be some difficulty in this part because of the video, but later on I'm going to show you how you can manually adjust the position of the ball. But for now, if you want to do it, if you want to let the auto tracker work, what you can do is you just drag on the corner here to enlarge the area of search. and click search, and now it should be able to detect the rest of the position correctly. I mean, if it doesn't, you can always do it manually. So now you can see from this view that there on the top right corner there is a graph of t versus x. So I'm just going to scroll and to let you see how the various tracks various position are captured. So now I can go to the individual frames to manually drag and select the position of the object being tracked. So this will get the software to measure the positions accurately. So now I'm going to go on to new frames. Since the rest of the frames are okay, I'm just going to leave it alone. As you can see, as you slide this, the coordinate here changes dynamically with the video analysis particles. So you can adjust, you can see that on both sides the graph will change accordingly. So I'm just going to check readjust the point number 8, and you can also look at the data which the results are shown in the table. So it turns red to indicate that that is the current position of the analysis. So I'm going to increase the plot to 2, but there seems to be a bug, so I'm going to select to toggle, try to get it to work. I'm going to toggle it back to y coordinate. This is the correct graph of y versus t. So as I drag the time frame again, you can see now that the two graphs are correctly plotted. Now I'm going to show you how you can do data analysis with this tracker software. Go to the plot area, right click and select analyze. And you can see that there's a data tool that appears. You can select the data by dragging on the table, which I find is more efficient. Check on the fitness graph and check on auto fit, and then you can see that the coefficients of the best fit equation appears. So A is actually set 1.772. You can ignore the exponential 0, which means it's the same number, and you can see that it corresponds to the equation. So B is actually a very small number, so I'm going to take it as 0. I'm going to key my data to show you how it is related to the equation of motion under constant acceleration, which is the equation which is usually taught to the students. So I'm going to change it to 1.772 times t. I'm going to toggle back to the analysis software to show you that the relationship between the equation in the x direction, x equal to 1.772 times t, because of the best fit data, allows me to come up with this equation. Click on the y-axis data, and same thing, you can choose a parabolic fit now because the graph is best fitted by parabola, and you can see that from the data it is related to the equation of motion in the following manner as shown. So I'm just going to bring the two graphs together to show you. So from the equation of motion, you can see that A, because of the fit of equation, A is actually the coefficient for the t square, so it's negative 5.202. So I'm going to change it on my data. So it's 5.202. And you can see that B, the second coefficient for t, is actually 2.436. So I'm going to change it to 2.436 for B. And C again is a very small number, which I'm going to ignore again. So you can change these two numbers and copy it over. I'm going to do it very quickly. So this is how you can use the tracker to study projectile motion. go get the tracker software and start learning physics in the meaningful way.